Hi everyone and welcome back to some ACT Prep Math with Blackboard Biology. So today we're going to look a little bit at quadratic expressions and equations. And so let's start off by first kind of defining what a quadratic is. This one says, which of the following are quadratic equations? Well, the kind of definition of a quadratic is it is a polynomial of degree 2, meaning that of all its terms, the highest exponent that you'll see, the highest degree term, will be x squared or some other variable squared. And so let's take a look at these equations, and I'm going to we're going to go through and mark and circle which ones are quadratics and which are not. So if you are following along and you're one of my Sky High students, this is going to be your quadratics exercise 5, number 1. On your assignment for today. So the first one I see is 3x minus 7 equals 14. Well, the highest degree term there would just be 1. It's just x. So this is not a quadratic. I look over here at the one to the right on the top, x plus 7 divided by x equals 20. That as well, there's no way that's not going to be anything of degree 2. Now I look here at something interesting on the second row, the first one right here, where it says x minus 5, and that's in parentheses, times x plus 3 in parentheses. And what I notice about that is that to do this polynomial multiplication here, I would need to, I could use the quote-unquote FOIL method where we do first, outer, inner, last. If you're familiar with that, I'll explain that in a moment. But when I multiply these together, this x times x, as I distribute this, that will become x squared. So this is, in fact, a quadratic equation. I look over here beside it. This for sure is a quadratic equation. X squared plus x equals 1. Below it, that is not a quadratic because its highest degree is 4, x to the 4th. Over here we have the square root of x minus 5, not a quadratic. Below this, we have x cubed, not a quadratic. And the very last one, yes, it is in fact a quadratic, again, because the highest degree term is x squared. So we're only 3 out of those that were quadratic equations. And so what we want to do next is we'll look at another example, now that we can kind of identify them. We'll look at another example, and we're going to see how can we expand or do polynomial multiplication. How can we expand a quadratic expression or equation fully out using either I'll actually show you 2 ways, the FOIL method and then another method of polynomial multiplication known as often referred to as the window method sometimes, because of the way we can kind of draw it out and use something that looks kind of like a Punnett square, if you've ever learned about Punnett squares from biology class. So this one says, and again, if you're Scott High students, this is exercise 1. Exercise 1, number 3. The expression 4z minus 5 times 5z plus 4 is equivalent to which of the following? And so we're simply going to expand this out. Now, I'm going to rewrite it as, let me switch colors here. I'm going to rewrite it as 4z. I don't like when they use z's. My z's look like 2's, but I'll put a little line there so we'll know. 4z minus 5 and 5z plus 4. Okay, so the first way that I'll show you is what is known as the FOIL method. You've probably heard this before. And what we would do, FOIL stands for first, outer, it would help if I could spell, inner, last. And in each of these, we're referring to the terms that we have here. So the first term of each factor here, we will multiply together. We're going to distribute. And so first would be these two. All right, so 4z times 5z. 4 times 5 is 20. Z times z is z squared. Then, so that's first. Then we want outer. So they're going to refer to this right here and this right here as our outer terms. 4z times positive 4. Well, 4 times 4 is 16, so 16z. Okay, check, check. All right, now we want the inner terms, and we're going to refer to these two right here as the inner terms. They're in the middle if we're looking at this. -5 times 5z. -5 times 5 is -25z. And then we'll do, that was these two, and then we'll do the last two terms. -5 times +4 is -20. Okay, so now what we have to do is something we call combining like terms. So I want to take all the terms that are the same degree and put them together. So I'm going to look right here and I'm going to see, are there any other z² terms in my expression now? And I do not have any. So 20z² will stay the same. 16z, are there any other just plain z terms? Yes, -25. So 16 minus 25 is going to be -9z. And I'm left with just this constant of 20. And so that is my final answer. So we FOILed it out. So 20z² minus 9z minus 20, that's choice D. Okay, that is one way to do it. That's one way to expand these and multiply the factors back together to expand the expression. Another method, I'm going to show you another way of doing it. This was FOIL, so let me clear everything and let me show you another method. Now, again, we already know that it's going to be D and so I will leave that there. Oops, excuse me. I'm going to grab this and move it up here. So this is what we're working with. So what I'm going to do in order to use this window method, I'm going to draw kind of this lattice, this table looking thing. And what I'm going to do is I'm going to write out each factor, and each term in the factor will get a space in this. Now again, if you've had biology class, you've ever done Punnett squares, this is very similar to a Punnett square. So notice each term is set up in its own little space here, right above the column in the table. And so I'll take the other factor here, 5z plus 4, and I'll write its terms over here. We're doing the same exact thing as FOIL. It's just this, for some people, this works a little better. One of the reasons I really like this, and I'll show you this in a moment, is you can do this with larger polynomials. FOIL gets confusing and kind of breaks down a little bit when you start looking at polynomials with 3 or 4 terms or more. This will work with polynomials of any size. And so what we're going to do is we're going to take each term and its spot and multiply them together. So to get this box right here, we're going to take this term and bring it in, and this term and bring it in, and multiply them. 5z times 4z is 20z². Over here, we're going to bring this term over to here and bring this term in and multiply them. 5z times -5, -25z. Same thing here. I'm going to bring this term down to here and this term over and multiply them. 4z times 4. Okay, and then I'm going to take the last two terms, and this one's brought over here, this one's brought down. 4 times -5 is -20. Now I drew those arrows. In reality, those are not necessary. Don't draw your arrows every time like that. It's going to clutter things up. That just kind of shows you where we're pulling these numbers from. And so whatever is in the column and the row you bring together to multiply for that particular box. Well, if you'll notice, we're going to get the exact same thing. It's just another method. And so finally, I'm going to take the like terms and combine them again, just like we did before. And so we arrive at the same answer. That's two methods of doing that. And so I encourage you, learn both, but go back and rewatch and pick one that works for you. And we're going to roll on to the next one. This one, and here is especially why. Here's a good example of why I like this. Z plus 4 cubed. Z plus 4 cubed. Now I can go ahead and tell you right now that there are some answer choices we can mark out. Obviously, z plus 4 quantity cubed is not going to be 3z plus 12, and it will not be a z squared because z will end up getting cubed. And so it's going to be either C, D, or E. So let's look together and find out. Now, realistically, if this is the actual ACT, I'm going to go ahead and I'm going to mark out C and D. Those are way too small. Notice this is a plus 4, so there's no opportunity for anything to cancel out. So there needs to be more terms in it. So before we even work it out, we're going to know what the answer is. It's going to be E. That's an easy one based on the answer choices. But let's go ahead and begin to work it out. So I'm going to have z plus 4 cubed, which is really this right here. Z plus 4 times z plus 4 times z plus 4. That's what z plus 4 quantity cubed is. Okay, so what I'm going to do first is I'm going to take these two factors and multiply them together. And then I'll take that resulting quadratic expression and multiply it by the last factor to expand this back out. So again, you could do FOIL or you could do the window method. I'm very quickly just going to kind of quote unquote FOIL it in my head, and then we will show you the window method to finish it out. So I'm going to get z squared, all right, z times z, then I'm going to get 4z and 4z, so that's 8z from a middle term, and 4 times 4 is 16. And then, of course, I have this other factor over here, z plus 4. Can't get rid of that. Now, this is why I like the window method. Look how many terms I have here in this particular part. I have 1 term, 2 terms, 3 terms. Well, FOIL would be a little bit confusing because FOIL only accounts for 2 terms in each factor. So what I'm going to do is I'm going to use the window method. And so I'm going to set it up. I'm going to say z squared plus 8z plus 16. Okay. And then over here on the side, I'll have z plus 4. And so doing it this way allows me to very easily have a nice kind of graphic organizer way of doing this. And so I'm going to have z times z squared is z cubed. Z times positive 8z is going to be 8z squared. Z times 16 will be 16z. 4 times z squared will be 4z squared. 4 times 8z will be 32z. And then 4 times 16 will be 64. Now I will combine like terms. Okay, so I'm going to end up with z cubed, and I'll kind of do a little check as I put them together. And then I have 2 terms that have z squared, 4z squared and 8z squared. Adding those together, I get 12z squared. 32z plus 16z is 48z, and then last I have 64. So that is why I kind of like that window method a lot better, is that I can more easily multiply polynomials when they get larger than 2 terms apiece. That's a little better than FOIL. And again, we're doing the same thing. We're distributing. It's just a distributive property. That's what we're doing. We're distributing. We're multiplying polynomials and expanding them out. And so again, if this was the real ACT, I wouldn't take the time to expand it fully out and do all that work. I would simply just mark off the answer choices I know are incorrect and arrive at the correct answer. So let's do another one here. Let's look and kind of compare some student work. So these are your least favorite problems to do, I'm sure. But these ones where you have to analyze some student work and make a decision about whether they are correct and where they went wrong, they're actually very good for you in learning your own skills of doing the math processes. So let's take a look here. It says Jasmine believes that x minus 2 quantity squared is equal to x squared minus 4 because x times x is x squared and 2 times 2 equals 4, and the minus sign must be preserved. Is Jasmine correct or incorrect? Well, I would hope that right away you would just very quickly see that this is incorrect, okay? So Jasmine is wrong Okay, this is incorrect. She is wrong. Okay, you can't simply take this exponent and say, oh, x squared, 2 squared, keep the negative sign. No, 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 no. This squared, okay, this exponent, if you can imagine drawing a line from it, the first thing that line would hit would be the parentheses. We are squaring everything inside of the parentheses. So she's incorrect. So she made a mistake from the very beginning. From the very beginning. She did not do this, expand this out correctly. And so let's take a look at that. X minus 2 quantity squared is really x minus 2 times x minus 2. And so she should have FOILed it or used the window method or whatever. She should have multiplied these factors out. We would end up with x squared minus 4x plus 4. That would be the correct equivalent expression to x minus 2 quantity squared. So she did that incorrectly. So you explain that in your own words, show the correct work, however you want to do it on your paper. That is what she should have arrived at. We'll take a look at one more like this and then wrap up the video. Jane has been asked to find the value of y squared given that x plus y equals 12. Okay, so if I was doing this, I would say x plus y equals 12. What is y squared? Okay. And she believes that the first step would be to square x and y so that the equation would read x squared plus y squared equals 12. So right away, Jane is incorrect. Okay, not correct, incorrect. You cannot say x plus y equals 12 and just come along and square both terms on one side and call it good. That's not how it works. You can't just apply exponents to one part of a side of an equation. If you were going to square something, sorry about that, you would need to square the entire side of the equation. But that also is not even what we should do first. Okay? And I believe this will actually help you if you're one of my Scott High students on another section of the work for today. What we need to do is simply solve for y first. Solve for y. Well, y equals 12 minus x. So y squared would be, let me switch colors. If we wanted to square y, we would square this side as well. That's now equivalent. So we're going to have 12 minus x quantity squared. And when we work this out, we would have 144. 12 times 12. 12 times negative x would be negative 12x. Negative x times 12 would be another negative 12x. That's going to be negative 24x. Negative x times negative x is positive x squared. Now, I like to rewrite these usually, so I'm going to kind of put it in its kind of final positions here that I like to normally have. I like to put them in order of degree. X squared minus 24x plus 144. That is equivalent to y squared. All right. And so I hope that this video has helped you. I know certainly if you're my students, this has helped you because I've given you some answers to some of your work for the day. But I hope that this video has helped you understand how to multiply polynomials a bit better and how to expand quadratic expressions and equations so that you can solve for solutions and just expand them out. And so, as always, thanks for watching. I encourage you to like, subscribe, comment, give me requests for future videos that you'd like to see. Have a great day.